Hello guys, welcome back to Math Zone African Motives, still on mathematics. And in this platform, we shall be focusing on differentiation. We've got some areas that we are given from this question paper. Question number 5 from the question paper of August 2021. Okay, so not wasting much time, guys. 5.1, we are given to differentiate with respect to x from first principles if given y is equal to ax squared plus bx plus c. All right, so that's 5 marks for that. Okay, so we shall just quickly rush through this question so that we see how we're supposed to differentiate this from first principles. So that's question 5.1. So we are given on question 5.1 f of x, which is equivalent to ax squared plus bx plus c. And we are asked to use to apply the first principles where we know that the first derivative with respect to x is supposed to be given as a limit, all right, as h is approaching to 0 of f of x plus h. So we've got f of x here plus h, all right, sorry for that. So we are just going to write our formula first, all right? So we just need our formula here. Then we can substitute what is required into the formula. Okay, so if you have to check here on our formula, we must find f of x plus h. So that means we are going to find f of x plus f of x is already there. This is our f of x. So we need f of x plus h. So you can even do the calculations aside, then you substitute into the formula. Okay, so let us just find f of x plus h aside here. That's in place of x, we are going to substitute x plus h. So it's going to be a into x plus h squared plus bx, which is plus b, into our x, which is now represented by x plus h, okay, plus c. All right, so you have to expand x plus h either by using your identities, where we know that this is going to give us x squared plus 2xh, all right, so that is going to be 2xh, or just expand the brackets aside. Let me just show here. We've got x plus h here and x plus h. So it's x times x, which is x squared, x times h, which is xh, h times x, that's plus xh, h times h, which is h squared. So that is going to be x squared. Here, same as 1 plus 1, which is going to be 2xh plus h squared. So as you can see, that's the same part that you're going to have in this case. So here, it's going to be x squared plus 2xh, then plus h squared, all right? So we can even use our identities to expand, or you can just expand by the brackets aside. Okay, so that's it. Then we move on to this side. Here it's going to be plus b times c times x. That's bx. Then we've got b times h, which is going to be bh plus c. All right, so a has to expand everything inside the bracket. So if we expand everything inside the bracket here, we are going to obtain a times x squared. That's ax squared. A times 2x is going to be 2axh, okay? Then a times h squared, which is going to be ah squared, okay? Plus the bx plus the bh plus the c as it is, okay? So this is our f of x plus h, guys, as we can see. But on the formula, if we are to check back again, we need f of x plus h minus f of h, okay? So this is what is going to happen here. We shall have the first derivative with respect to x as the limit h is approaching to 0 here. So it's going to be h is approaching to 0 of the f of x plus h, which is this part that we obtained all of this expression. That's ax squared plus 2axh plus ah squared plus bx plus bh plus c. Then we subtract f of x as per our formula here. This is minus f of x. So our f of x is this function of ax squared plus bx plus c. So we're going to subtract that. That is, open the bracket, then you subtract everything. So it's going to be minus, we open, that's ax squared plus bx plus c. Okay, everything over, all right? h. So that's from our formula there. So this is what you're going to have. So that's the first derivative with respect to x will be the limit as h is approaching to 0 here. We need to simplify. I want you to see something. If we are to use this negative, we are going to have negative times ax squared, which is negative ax squared. Negative times bx, which is negative bx. Negative times c, which is negative c. So that means if you are to simplify now together, you're going to have ax squared minus ax squared. So this will cancel. These are the same. We also have bx minus bx. This will cancel. We have minus c and we've got plus c. So c minus c will cancel. So which means we are going to remain with this part. We are going to remain with the 2ah, 2axh, ah squared, bh. Okay, all this part is cancelled because this is the one that we wrote on top. So this is the only part that you're going to remain with, which is 2axh plus ah squared plus bh, okay? Everything over h. So we know that we are supposed to apply the limit of h approaching to 0 there if we are done with the h in the denominator by cancelling or by removing the h in the denominator. So how are we going to do this? We are going to divide each and every term by h, or you can factor out h on the numerator, then you divide, or you can just divide each and every term by h. It's one and the same thing. So if you divide by h here, this is what is going to happen, guys. H is going to cancel here, h is going to cancel here, h is going to cancel here. Here there are two, so this is going to be h. So we are going to remain with 2ax, that's 2ax plus, this is going to be ah. There is one h remaining here, so it's ah plus h and h cancelled, you remain with b from this one. All right. So as you can see, we have used the h that was in the denominator here. So that means we can now apply the limits as h is approaching to 0. So what is going to happen if h is approaching to 0? That's wherever there is h, we are going to substitute as 0. So here it's going to be as 0. So a times 0, that's as 0. So we are going to remain, therefore, with 2ax. So our answer is going to be 2ax plus b. So that is the derivative that we are having with respect to x from first principles for that given quadratic equation. F of x is equal to, okay, so that was 5.1. Let's move on to 5.2 of the question. All right, so that's 5.2, differentiate with respect to x. So this one is with respect to x, but we are supposed to apply the product rule. Okay, so let's see how we can apply the product rule to differentiate. Y is equal to sec x times, so this is a times, this one, tan x. So it's not like sec x, then so it's a times to multiply, okay? So we are multiplying the 2 there. All right, so I can even write it aside here, guys, than to write it down there. Let's just write it here. So that's 5.2. We are given that y is equivalent to sec x. All right, that's sec x multiplied to tan x. All right, product rule. So how do we apply our product rule, guys? Remember that your product rule, you need just your formula where we know that dy dx is equivalent to, okay, if this is our u, a function with respect to x, and this is our vx, then the derivative, this one you're also given in the formula sheet, okay? So that's ux by the first derivative with respect to x plus the first derivative of ux multiplied by vx. So all you need is to find the derivative, then you substitute into the formula. So you can even try to work them out from our ux here. We know that our ux is equivalent to sec x. So this is sec x. Okay, so what's the derivative of u with respect to x? So if you differentiate sec, okay, this one, you're supposed to know this one from your formula sheet you're also given. So sec gives you sec x tan x. So that's sec x tan x, okay? We move on to the second one, that's vx, which is what? Which is tan. So that's tan x. So what is the derivative with respect to x for tan? So remember that tan gives us sec squared. So that's sec squared x. So these are the derivatives that we got. So we just have to substitute into the formula. so that our dy dx is going to be ux, which is our ux in this case, that's sec x, okay? So we're going to obtain, or we are going to have sec x in this case multiplied to the first derivative of v. The first derivative of v here gave us sec squared, so that's sec squared x, okay? Plus the first derivative of u, the first derivative of u here, we obtained sec x tan x. So that's sec x tan x. Whatever that you have here, you multiply to vx, of which our vx is tan of x. So this is going to be tan x. All right, so that's the first derivative, or dy dx. Sec and sec, this one is same as to the exponent of 1. So remember, you add the exponent, so it's going to be sec to the exponent of 3x. Then the same thing, tan times tan, that's tan squared. So you're going to remain with the sec x tan squared x. Yes, you can factor out sec x if you want, but you can even just leave it like that. That is the final answer that you're going to obtain if we are to find the derivative with respect to x of that given expression. All right, so I just hope we saw what we're supposed to do in this case. Let's check the other part. That's question 5.3. So that's question 5.3. Determine dy dx if we are given this whole expression. That's 5 marks for that. Okay, so we shall quickly have the question down. So we are given y, which is equivalent to, so that's question, okay, let us write 5.3. That's y is equivalent to -2 over the cot of x plus 2 over the square root of x to the exponent of 3 minus 5 over the sine of x, all right? Then plus 4 to the exponent of -3x plus 1 over 7 e to the exponent of 3x. So you need to find the derivative of y with respect to x. So before finding the derivative of y with respect to x, let us just try to rewrite these terms in a way that we can differentiate them properly. Okay, we've got -2 over cot. Remember that 1 over cot is a tan. So -2 over cot is going to be -2 tan of x. All right, we move on to this part back on our exponents. We can rewrite this as 2 over the square root of means to the exponent of a half. So it's x to the exponent of 3 over 2. All right. But remember, from our laws of exponents, if x is in the denominator having an exponent like this, we can write it in the numerator having a negative exponent. That's 3 to the exponent of -3 over 2. All right, so here we are going to obtain plus 2x to the exponent of -3 over 2. Okay, we move on to -5 over sine. Remember, 1 over sine, it's a cosec. So that's -5 cosec of x. Okay, 4 to the exponent of -3x, there's nothing that we can do here. E is the same as x here, is in the denominator, so you can write it in the numerator having a negative exponent. So it's going to be plus 1 over 7 e to the exponent of -3x. Once you have managed to write your expression or term in this format, that means we can find the derivative of y with respect to x. Remember, from our formula sheet, the derivative of tan, that's sec squared. So it's going to be -2 sec squared x. All right, we move on to x. Remember, if you are given an exponent like this, you have to multiply back to 2. So it's 2 multiplied to -3 over 2. Then on x, we subtract a 1. So -3 over 2, -1, which is going to be -5 over 2 if you simplify properly. So -2 and 2 cancels, you remain with a -3. So it's going to be -3x to the exponent of -5 over 2. The derivative of cosec gives us minus cosec x cot x. So this is minus cosec x cot of x. But there is a negative which is already there. So the negative and the negative multiplies each other. So it's going to be plus 5 cosec of x, all right, cot of x. All right, 4 to the exponent of -3. Okay, I already indicated these derivatives. If you want some of the videos that we had, remember I told you guys the derivative, if you are given to find the derivative of k a to the exponent of f of x like this, we are going to obtain the first derivative with respect to x by ka to the exponent, as it is k a to the exponent of f of x, ln of a, like that. So in this case, our f of x, this is, we do not take, our k is like we got a 1, so k is a constant, okay? So this is our a, and this is your f of x. So you need to find the first derivative with respect to x here, which is on our f of x. If you find the derivative of negative 3x, that's negative 3. All right, multiplied to k, which is a constant, and the constant here is a 1, so there's nothing to write. A to the exponent of f of x, we remain with 4 as it was, to the exponent of 3x. Ln of a is the base, which is our base. In this case, it's 4. So it's ln of 4. Okay, so that's the derivative that you're going to obtain. You move on to e, is applying the same thing, just like what we had on this one. So we are going to have our first derivative, which is the first derivative of f of x, that's negative 3. All right, so it's going to be negative 3, but there is over 7. There's a 7 there. So it's going to be negative 3 over 7. Then we move on. K is the constant, that is the over 7 there. Okay, a to the exponent of f of x, this is our e to the exponent of 3x. So we've got e to the exponent of negative 3x. Ln a, so it's going to be ln of a. A is the base, which is e, so that's ln e. Or we can just remove the ln e, since we know that ln e is equal to 1. So you can just remove that, or you can even leave your answer like this. So that's what you're supposed to know, guys, if you are dealing with derivatives. So that was a basic question that we had with 5 marks. So question 5.3. All right, so that was 5 marks. Then we move on to question 5.4, where we are given the application of our differentiation. Okay, determine with aid of differentiation the coordinates of the minimum and maximum turning points given this equation, and distinguish, okay, and distinguish between the maximum, and take note, we are given that you're supposed to distinguish them, okay, using the second derivative, and that's 7 marks. Okay, so let's see, guys, what we're given. So this is a cubic function. Then we need to find the turning points. All right, so remember, I told you guys that at any turning point, the first derivative with respect to x must be equal to 0. So this is y, which is equal to x cubed minus 6x squared plus 9x minus 18. Okay, so at any turning point, as long as it's a turning point, the derivative of y with respect to x must be equal to 0. So that means in this case, we are supposed to find the derivative of y with respect to x. Okay, so that's here. It's going to be drop here 3 times 1, that's 3x. You subtract 1 here, which is x squared. We drop the exponent, 3 times minus 2 times 6, that's minus 12x. Okay, on 9x, this is going to be a plus 9. Then if this one is a constant, we know it's going to give us a 0. So the first derivative with respect to x, we know it must give us a 0. So that is what you're going to do now. So you're going to equate now 3x squared minus 12x plus 9. We equate it to 0. The moment you equate this to 0, what do you have now? You now have an equation. So all you need is to solve this equation. All right, so how do we solve this equation, guys? The quadratic equation, we can even try to reduce this equation by 3. 3 is common throughout. So we're going to have here x squared minus 4x plus 3 here, which is equal to 0. So using your factorization, we need 2 brackets, which is equal to 0x and x here. What are the factors of the constant term, which is 3? But if you add them, you must obtain a negative 4 in this case. So if you have to check for 3, we've got negative 3 and negative 1. If we multiply these two, you're going to obtain a positive 3. If we add, that's a negative 4. So these are the factors that we are going to use: negative 3, negative 1. So x is going to be 3, or x is going to be equal to 1. From the 0 concept, x minus 3 is equal to 0, or x minus 1 is equal to 0. Then we obtain the values of x, which is 3 or a minus 1. So what you need now is to find the exact point, because these are the values of x at the turning points. So how are we going to find the exact turning? We are now getting back to the normal equation that we are given, the original equation here, where we are given y. So we are going to obtain our turning points now. So we are going to have the first turning point where x is equal to 3 or where x is equal to 1. I don't know which one are you going to use. So I'm going to start with 3. Okay, then the second turning point where x is equal to 1, then we find the equivalent value of y. So in this case, we are going to substitute back into the original equation where x is equal to 3. In place of x here, you are going to substitute 3. So that will be y is equal to 3 to the exponent of 3 minus 6, 3 to the exponent of 2 plus 9x, that's 9 times 3 minus 18. And if we substitute properly, we are going to obtain negative 18. So when x is equal to 3, we are going to obtain negative 18. You do the same when x is equal to 1, you are going to obtain something like negative 14. Okay, so these are the turning points that you are given. So the question is not about finding only the turning points, but also we are supposed to differentiate these turning points. Take note here, we are given to differentiate between maximum and minimum turning points using the second derivatives. Okay, so how do we apply the second derivatives to determine the nature of the turning points? Okay, this is what you're going to have. The second derivative with respect to x, all right? The second derivative with respect to x, if it is greater than a 0 like this, that means that one is a minimum turning point. If the second derivative with respect to x is giving us a value that is less than 0, that's a maximum turning point. When I'm saying a value that is greater than 0, I'm meaning your answer is a positive. When I say the value is less than 0, I say the answer that you get is a negative. Okay, so remember we had our first derivative with respect to x before, which we got here. Let us get back here. This was our first derivative with respect to x. If you still remember, we got this as 3x squared minus 12x plus 9. This was the first derivative with respect to x. So what you're going to do is to differentiate again now to find the second derivative. Okay, so your first derivative, I'm just going to rewrite this first derivative. We were given it as 3x squared minus 12x plus 9. So now the second derivative with respect to x is going to be 3 times 2, which is 6x minus 12. So that's why I'm saying at this second derivative, if you are to substitute from the turning point, this is your first turning point, this is your second turning point. All right. So from the first turning point, from our first turning point, our x is equal to 3. So using the value of x, which is 3 here, if we are to substitute our x, which is 3 here, okay? This is going to be 18 minus 12, all right? If we are now substituting the value, so it's now 6 times 3, which is 18, then minus 12, which is going to be a positive 6. So as you can see, the value is a positive. So if it is a positive, that means it's a minimum turning point, because a positive, if the second derivative gives you a value which is greater than 0, then that's a minimum turning point. So it means our first turning point here is a minimum turning point. Okay, we move on to the second turning point. X is equal to 1 on our second turning point. So on our second turning point, x is equal to 1. So if you substitute x is equal to 1 here, we are going to have 6 multiplied by 1 minus 12, which is 6 minus 12, that's minus 6, which is a negative. That's a value that is less than 0, less than 0. So it means it's a maximum turning point. So the second turning point, which is TP2, is going to represent the maximum turning point. So that's how you differentiate between the minimum and the maximum turning point using the second derivative. So the question is for you to apply or to use the second derivative to differentiate or to state this is maximum or this is minimum turning point. So that's what you had, guys, from derivatives, August 2021 question paper from Mason African Motives. Till we meet again.